Okay, on this lesson, we're still talking about angles, but we're going to get a little bit more specific and talk about some special types of angles. I actually took a picture of these key concept boxes from the book, put it on here. I just thought it'd be a little quicker and easier instead of writing everything down. Hopefully this will go a little faster. I'm really trying to get these videos around 20 minutes, 15 to 20 minutes. I'm not doing a great job at it. I'm really trying to get everything covered, and I don't want you to miss out on anything. But anyway, let's see what we can do here. Let's take a look at some words. And most of this lesson today is basically just definitions and learning things. Now, I'm not going to ask you to write down a definition on a quiz or a test or anything, but I definitely will refer to these things over and over again. And they might ask for them in a question. They'll say, name the adjacent angles or name the linear pair. And you have to know what they're talking about. So you might not have to write down the exact definition, or I know for sure you're not going to have to do that, but you need to know what they are and what they mean. All right, let's take a look at the first one. That would be adjacent angles. Adjacent. Well, first of all, that word adjacent basically means next to. If I had two houses next door to each other, I would say that those houses are adjacent to each other. And you'll hear that word a lot, to tell you the truth. Not always in geometry, but you'll hear people say the word adjacent for things that are next to each other. So look for that every once in a while. Listen to what people are saying, and every once in a while you might hear somebody say adjacent. Teenagers don't use that very often, but a lot of adults might use it, and you could add that to your vocabulary list to use in just regular language. Okay, let's keep going. What are they? They're two angles that lie in the same plane, right? Which means they're all like on one sheet of paper, basically, and have a common vertex. Let's take a look at these two right here. This is angle 1 and angle 2. Now, I don't think I've shown you this, and I probably should have shown you this in the other lesson we talked about angles. But here's another way you can label an angle. And this is a nice, easy way to label an angle. You could just put a number in between the two sides of the angle. That means this angle right here is angle 1, and then this angle right here is angle 2. And that's a nice, easy way, instead of using like this, A, B, C, and all that kind of stuff. It just makes things a little bit easier for us. So if you look at 1 and 2, what does it mean to be adjacent? Well, they first have to have a common vertex. So that's the first thing, is a common vertex. Do these two angles, do 1 and 2, share the same vertex? Absolutely. Okay, angle 1 has this point as a vertex, and angle 2 has this point as a vertex. The second thing is they must have a common side. Look at angle 1. Angle 1 has this side right here. Okay, that's a ray. That's part of angle 1, and it's also, this side is also one of the sides to angle 2. So both of these angles have angle 1, or I'm sorry, have this ray right here in the middle as a common side. So yes, so number 1, that's true. Number 2, common side, yep, that's true. This one's the one that, if you just read this yourself, you may not understand what it means. It says it has no common interior points. That means we did talk about interior points. If I had an interior point in one angle, can that same point right here be shared by both of these angles? Can it be in common with both of the angles? And the answer in this case is no. Anytime I put a point inside one of the angles, there's no way it's also going to be inside the other angle. So if I picked some points in angle 1, there's no way that that point is also in angle 2. Well, some people might say, what about right here? That's in both of them. Well, good try, but it's really not in any of them. It's on the angle, okay? We're talking about interior points. They have to be inside of the angle. That's not inside of the angle. So all three of those things are true. So guess what? Angle 1 and 2 are adjacent angles. So 1 and 2 are adjacent. This is the most common looking type of adjacent angle. Let's look at this. Let's see if 1 and 2 are adjacent here as well. Do they have a common vertex? Check. Do they have a common side? That would be, let's get rid of that little dot. Do they have a common side? Absolutely. Angle 1 has this side right here, and angle 2 also has this side. Say angle 2 has this side, angle 1 has this side. So absolutely. So check on that one. No common interior points. Is there any way that I can put a point in angle 2 and it also be in angle 1? No, there's no way. So that means that there's no common interior points. So yes, that is adjacent. So 1 and 2 are adjacent angles here. They're next to each other. And 1 and 2 are adjacent angles here. They're next to each other. All right, let's look at some non-examples. Let's see some situations where they're not adjacent. Let's take a look at this. Angle 3 and angle ABC. So angle ABC is this whole, it's not very straight. Let's try to make a straight line here. Angle ABC is this whole big angle right there. Okay, that whole red angle, that's ABC. So we're looking at that big angle and angle 3. So let's take a look. First of all, do they have a common vertex? Yes, they do. Angle 3 has this point B as a vertex, and angle ABC, the big angle, has this point as a vertex. So number 1 is true. So far, it's an adjacent, they're adjacent angles. What about 2? Do they have a common side? Angle 3 has this and this. So yeah, they do. Look, this side right here is in angle 3, and it's also part of angle ABC. So yes, it does have a common side. So far, they're adjacent angles. But they gotta all 3 be true. I forgot to put a 3 right here. Okay, they all 3 have to be true. Do they have any common interior points? What does that mean? Is there a point that's in the interior of one angle that's also in the interior of another angle? So let's put a point right here. Is that point in both of them? No, it's not. Okay, so far, no common interior points, because this point right here is in the interior of angle ABC, but it's not in the interior of angle 3. But guess what? What if I put a point right here? Okay, that point is inside in the interior of angle 3, and it's also in the interior of angle ABC. So what does that mean? This says there can be no common interior points. Well, look at this point right here. That is a common interior point. It's in angle 3, and it's also in angle ABC. So even though 2 of these things were true, the third one is not true. So is angle 3 and angle ABC, are they adjacent angles? No, they're not. That's why they call it a non-example. Let's look at this. Let's look at ABC here. Here's ABC. Angle ABC right there. So this whole thing right here is angle ABC. And this right here is angle 3. All right, or I could have just put a little arc and a little arc. This is angle ABC. This is angle 3. Are they adjacent angles? Well, let's go through the list. Do they have a common vertex? Well, the vertex of angle ABC is right here. The vertex of angle 3 is right here. So right away, I can say that they are not adjacent angles. So these are not adjacent angles. All right. Now, they don't have any common interior points, but they also don't have a common side. Angle 3 has these 2. Angle ABC has these 2. They're not common sides. So 2 of these things don't work. One of them does, but if just one of them doesn't work, they're not adjacent angles. Hope that makes sense to you. Let's go to another word, which is a linear pair. We kind of talked about this a little bit. Maybe not. Anyway, let's look at it. A linear pair. Linear means a line and a pair. A pair of what? What do you think? We've been talking about angles, so we're probably talking about a pair of angles that make up a line. That's exactly what linear pair is talking about. It's a pair of adjacent angles. Okay, we just discussed what adjacent angles are, with non-common sides that are opposite rays. You think, okay, that's a lot of words. So what does that mean? They have to be adjacent and they with non-common sides that are opposite rays. So look at this. This is the common side right here because they're adjacent. That's the common side. But look at the 2 non-common sides. Let's do those in a different color. Let's go with the green here. Watch. That would be they're opposite rays. The non-common sides, this green one here and this green one here, are the 2 sides of those angles that are not common with each other. Okay, and they're opposite rays. So guess what we have? We got a linear pair. Now that's pretty confusing definition, to tell you the truth. How do you know what a linear pair is? Basically, it's this. Okay, it's basically 2 angles that form a straight line. Okay, did you get that? If I have 2 angles and it makes a nice straight line, look at 1 and 2. That's a straight line. It makes a straight line. If I have 2 angles, angle 1 is here and angle 2 is here. If I have those 2 angles, they form a straight line, then I have a linear pair. All right, that's more of a basic definition. This is a little more specific, but that's kind of a basic definition for you just to look to see if it's a linear pair. Let's see this non-example. Angle ADB. Where's ADB? ADB, that would be this angle right there. See, ADB. And angle ADC. Angle ADC. Let's do that in a different color. And I'm going to put two arcs because they're not necessarily equal to each other. All right, so look at this little green arc and look at this orange arc. Do they form a straight line? No, they don't. Now, they are adjacent to each other, but look at the non-common sides. That would be DB and DC. They are not opposite rays, are they? Nope, because it makes an angle. It bends. It doesn't make a straight line. So these two angles do not make a straight line. That's why they call this a non-example. So this is not a linear pair. Remember, a linear pair are two angles that make a line. See that word in linear? That word line? That's what we got going here. All right, let's look at the next thing. The next thing you're going to see a lot of. Let's scooch this down. I got that little black line in there. Okay, it's a little bit better. All right, let's take a look at this. Vertical angles. Now, vertical angles are really super important, and you're going to use this quite a bit. Let's see what they are. They're two non-adjacent. So they're not going to be adjacent to each other, and they're formed by two intersecting lines. Basically, if you do this, if you just take two lines and you intersect them, you're going to get two pair of vertical angles, and they're the angles that are across from each other, the non-adjacent. See how 1 and 4, they would be adjacent to each other. 1 and 3, they would be adjacent. So which ones are non-adjacent? They're the ones that are across from each other. So angle 1 and 2 are non-adjacent, and they are vertical angles. And then also 3 and 4 are across from each other, and they're vertical angles as well. And we're going to learn something a little bit later. I'll tell you right now. I'll give you a little free preview. If you look at angle 1 and 2, they are vertical angles, and they are actually equal to each other. It doesn't matter how you draw your two intersecting lines. You're always going to get two pair of vertical angles. Here's one pair. They're going to always be equal to each other. The vertical angles will always be equal to each other. And a little bit later on, we'll talk about why they are. But right now, I'm just telling you that the vertical angles, the angles that are across from each other, these two are across, these two are across. They will be equal to each other. That's kind of, they haven't talked about that in this lesson, but they eventually will. Let's keep going. Let's look at this non-example. Remember, they're two non-adjacent angles. So let's take a look at angle AEB. Where is that? AEB. That would be this one right there. And DEC. DEC. That would be this one right there. Are they vertical angles? Well, you look at it and you're like, yeah, they're kind of across from each other. Okay? But it says the angles are formed by two intersecting lines. Here's one line. See AC? That's one line. But look at this. Look at DEB or DB. Is that a line? No, it's not, because it comes to E and it kind of breaks down a little bit, right? It goes down a little bit. So this is not a straight line. DEB or DB or BD is not a straight line. So you can't have vertical angles. Even though they do look like they're across from each other, they're not across from each other from two intersecting lines. They have to be two straight lines. They can't have a little bend to it like this. So that's why it's a non-example, and these are not vertical angles. Okay, here's another key concept thing. I'm just going to use the thing that I took a picture of from the book. A little easier. Sorry, this is not as clear as the other one, but you'll get the idea. Well, remember what I said about vertical angles? Sure enough, look, in the next key concept, they tell you something that's true about vertical angles, that vertical angles are congruent to each other. So that's a pretty big deal. If you look at this right here, I've got two lines that intersect each other, and I've got vertical angles. It's kind of hard to see right here. Let's do this in a different color. Let's use this darker purple. So this angle and this angle are equal to each other because they're vertical angles. If you look at it, it's angle ABD and CBE. Those two angles are vertical angles, and you have a couple other vertical angles as well. I'll do these in green. Again, I'm just going to write over that red because it doesn't show up that great on this. And then these two angles right here are going to be vertical angles. Let's read them off. Got to make sure we know how to read off these angles. It's angle ABC, okay, which is right here. What's this angle? Angle DBE. which is this one right here. And they are congruent to each other because that's one of the things that we have learned. We're going to have a theorem. We're going to learn it later. We'll worry about what theorems are some other time. But that's very true, that the vertical angles are congruent, are equal to each other. And that's super important. You don't know how important that is. We're going to use that a lot throughout the rest of the book. Maybe not in every single chapter, but a whole lot of times. You'll be surprised about how many times that actually pops up, that vertical angles are equal, or you could say are congruent. Let's go to the next thing. Let's talk about complementary angles. Well, complementary angles are angles that have a measure sum of 90 degrees, which means they do what? They add up. Just write this down. They add up two angles that add up to 90 degrees. I mean, that's what it says, but it's just a little fancier here. But two angles that add up to 90 degrees are complementary angles. Let's take a look at this picture right here. Let's make this a little bit bigger. There we go. It's a little easier to see, I think. Let's take a look at these two angles. Look, remember what that little box right there means? Should have done that in red. That little box means it's a 90-degree angle, which means it's a right angle. So two angles that add up to 90 degrees. So look at angle 1. Angle 1 goes from here to here, and angle 2 goes from here to here. So those two angles form this one big angle, and that whole big angle is 90 degrees. And so we call that complementary, right? Complementary angles are angles with the measures that have a sum of 90 degrees, or they're two angles that add up to 90 degrees. Let's take a look at this. Now these two angles happen to be adjacent to each other, but complementary angles don't always have to be adjacent to each other like they are here. They could just be two completely separate angles. But if angle A is 65 degrees and angle B is 25 degrees, if you add those up, that's actually 90 degrees. Even though they're not adjacent to each other, they still are two angles that add up to 90 degrees, and these two angles, A and B, are still complementary angles. Let's make this a little bit smaller so I can read the whole thing. Let's look at the next thing. So if I have two angles that add up to 100 or to 90 degrees, almost gave it away. What about adding up to 180 degrees? All right, we call them supplementary angles. Complementary is 90. Watch. Complementary is 90 degrees, and supplementary is 180 degrees. A lot of people get mixed up on which one's which, but it's kind of easy. Look at alphabetical order. C comes before S, complementary before supplementary. So this is going to be smaller than this. 90 is smaller than 180. C comes before S, 90 comes before 180. So complementary is the 90 and the supplementary is the 180. I think that's an easy way to remember it. Just remember alphabetical order. C is 90. C is smaller, S is bigger, okay? Just alphabetical order. I think that's a good way to remember it. All right, let's do this. Let's blow this up just a little bit, enlarge it a tad, just so we can see it a little bit better. So what do we got? Supplementary angles are two angles that have a sum of 180 degrees. So let's come over here. Let's take a look at this 3 and 4 one first. Look at this angle right here is 3, and that's a huge obtuse angle. Look at that big angle. I'll put two arcs just to show that they're not equal to each other. So angle 3 and 4, they form a straight line. It's a linear pair, isn't it? We just talked about that a little bit ago. So these two angles form a straight line, and a straight line is 180 degrees. And so 3 and 4 are supplementary. It's a little thick, but that's okay. Supplementary angles, okay? They're supplementary angles if they add up to 180 degrees. These happen, now they don't say, I mean, they don't actually give you the measures of the angles, so how do I know they add up to 180? Well, it's because they form a linear pair or a straight line, and a straight line is 180 degrees. Look at angle P and Q. They don't even have the same vertex or anything. They're not even on the same line, right? But they told us that this was 120 and this was 60. So if this is 120 and this is 60, what do they add up to be? They add up to be 180 degrees. And if two angles add up to be 180 degrees, then they're supplementary, all right? Let's see what we got here. And we've kind of discussed this already, but they throw it in here. It says the angles in a linear pair are supplementary. We just talked about that with this 3 and 4, okay? So look at 1 and 2. Angle 1 is here, angle 2 is right here, and they're a linear pair, and so they're supplementary, which means they add up to 180. So I can say that angle 1 plus angle 2 equals 180 degrees. Okay, here's an example for what we were just talking about, supplementary angles. It says, find the measure of two supplementary angles if the difference in the measures of the two angles is 18 or 18 degrees. When it says measures, they don't have to say 18 degrees. If they just said the difference in the two angles is 18 degrees, they could do that. All right. So find the measure of two supplementary angles. Well, here's two angles right here that are supplementary. I've got angle 1 and angle 2. So I drew the picture out. This is a key thing that you need to do all year is if they give you a word problem like this, you need to draw out the situation so you can visually look at it and see what's going on. So I've got two angles. We'll just call one angle 1, the other angle 2. In fact, I'm not even going to label it because I'm going to do this. I want to find the measure of both of these angles. Well, look, they don't give me anything to work with. They just say that the difference in the measure of the angles is 18 degrees. All right? But I do know something, though. I do know that this angle plus this angle equals 180 degrees. The problem is I don't know either one of those angles. So what I'm going to do is this. Let's call one of them, just call one of them x. So if I call one of them x or x degrees, what am I going to call the other one? Now this is where people get really hung up. Okay, if you can get this early on, it's going to save you a lot of hassle throughout the rest of this year. For instance, let's do another example. You can keep that x there, but I'm just going to get rid of it for a second. I'll come back to that. What if this right here, I'm just going to make up something. Let's say that was 80 degrees. Let's say this angle right here was 80 degrees. How would you find this angle right here? Remember, it's a linear pair. Okay, what do they add up to? They make a straight line, so they add up to 180. So if this is 80, guess what this is? This has to be 180 minus 80, which is 100. So this would have to be 100 degrees. If this was 80 degrees, this would be 100 degrees. All right, I hope that makes sense. Now, let's go back to that x thing. Let's get rid of all this. What if I said that this was x degrees? Okay, that stands for any number. How do I find its supplement? The supplement of this unknown angle. Well, remember, when this was 80, how did I figure this one out? I went 180 minus 80. But I don't know it's 80, right? I don't know what angle it is. I know it's x, though. So how would I find this? I would go 180 minus x. That's how I would write it. Now that's a little confusing at first. Maybe when you come back to class we can kind of go through a couple other ones and explain it a little bit better. But if I call one of them x, the other would be 180 minus x. Now it says find the measure of the two supplementary angles if the difference, what does that mean? The difference means the subtraction. You're going to subtract the two angles from each other. And the answer to the subtraction problem is going to be 18. So what am I going to do? I'm going to take this x and this 180 minus x. I'm going to subtract them. And when I subtract them, my answer should be 18. And then I can solve for x. Let's just pretend it was the 80 and the 100. What if I took 180 and I subtracted them? Is the difference 18? No, it's not. It's close, but it's not. If this was 100 and this was 80, 100 minus 80 is 20. The difference is not 18. You don't want to just guess a whole bunch of numbers and just throw them in. This is exactly how you want to set this thing up. So the difference, so I'm going to take 180 minus x, and I'm going to subtract the other angle from it. So I'm going to subtract an x. That's the difference of the two supplementary angles. And what's our answer? The difference is the answer to a subtraction problem. So if I subtract these from each other, my answer should be 18. Now what am I trying to do? I'm trying to set up an algebra problem so that I can solve for x and then I can figure out what this angle is right here. Once I figure out what this angle is, I can find this angle by taking it away from 180. So let's do this. This is 180 minus x is minus 2x. That equals 18. Let's do this. We could do this a couple ways. I'll just do it the way that I like to do it. Okay, I'm going to add the 2x and put it over here just so I can have a positive 2x. Then I'm going to take the 18, I'm going to move it over here, and I get rid of it by subtracting an 18. I hope you see that. I added a 2x, and I subtracted a 118. Or an 18, not a 118. So that would be, what, 160 2. Let me double check my math here. Yep, 162. And this way, it's positive. If you look in the book, they kept the x on the left-hand side, and you got negatives, and you can do it that way, and that's fine. This is just how I would like to do it, because I always like to get a positive x. Divide both sides by 2, and so x is 81. Is that one of my angles? Absolutely. This angle right here, I said, was x, didn't I? So this angle is 81 degrees. Now, how do I find this angle right there? Well, I take 180 and I subtract 81. And if you do the subtraction, that's 99 degrees. So this is 99 degrees. So let's see if I was right. Is the difference in the two angles 18 degrees? Well, 99 minus 81 is 18. Sure enough, it checks and it works. So one of the angles would be 99 and the other angle would be 81. I'd circle both of those because it says find the measure of two supplementary angles. All right, let's talk about another thing, which is perpendicular lines. Perpendicular lines, if you look at it, they intersect to form 4 right angles. And you look at this, you can say, well, I don't see 4 right angles. Well, I do. Watch. That's one right angle. Remember, these are a linear pair, so they have to add up to 180. So if this is 90, what's this angle right here? Angle B, whatever that middle one is, D. This one right here, that would be 90 as well, because 90 and 90 are 180. What about this one? Well, these two have to add up to 180, so that has to be 90. What about this one? Well, these two have to add up to 180, and these two have to add up to 180. So if they're both 90, that has to be 90 as well. So there's your 4 right angles. And also, they intersect to form 4 congruent adjacent angles, okay? All, like this one and this one are adjacent, okay? And they're equal to each other. This is 90 and this is 90. These two are congruent, okay, and they're adjacent. These two are congruent, they're adjacent. These two are congruent, and they're adjacent. So that's true. It says segments and rays can be perpendicular to lines or other line segments and rays. Let me show you what they're talking about here. So it says segments and rays can be perpendicular to lines. So let's have a segment. All right, so we'll say that that's a line segment, and that can be perpendicular to a line. So I could have a line that goes like this, and this line could keep on going forever. And if they form a right angle, if that line and that segment form a right angle, then they're perpendicular. So they don't have to be lines, okay, perpendicular lines. You can have perpendicular rays, you can have perpendicular line segments, you can have perpendicular lines, and you can have a mixture of all those in between. All right, here's the symbol for perpendicular. I think we've discussed that already, is that little box right there. Okay, so let's do this. Get rid of all that. That's the original box that they had. So that little box right there means that they're perpendicular. That little box right there, same thing, and it means that they are right angles. What's the symbol for perpendicular? Here it is right there. And it just looks like 2 lines that form a right angle, doesn't it? So this is the symbol for perpendicular. So if I took a look at this, this is line AD. So that's line AD. Put the arrows over top of it. It's written right here, but I'm going to write it anyway. It's perpendicular to this line right here. I could have called it CB or BC. It doesn't make any difference. I'll just be different and call it BC. Right? And that's how you would say that those two are perpendicular. How do you know they're perpendicular? Because they tell you that they're perpendicular because of that little box that they put in there. The right angle symbol is what the book calls it. Okay, sometimes we just call it the box. Let's do an example. Okay, here's an example they have for the perpendicular stuff that we talked about. Let's see what they tell you. It says find x and y. All right, so we're trying to solve for x and y so that line PR and SQ are perpendicular. So here's SQ and here's PR, and it says find x and y so that it makes it perpendicular. So if it makes it perpendicular, that must mean that I'm going to have a right angle. Now, you can put it anywhere, but I'm going to put it right here because I thought ahead a little bit. Because look at this angle, this 2x, and look at this angle, this 5x plus 6. That forms a right angle. Remember, all 4 of these are actually right angles, aren't they? Okay, I could have said that that was a right angle. I could have said this was a right angle. But this is going to help me out a little bit. How's that going to help me out? Well, if I want to solve for x, and this is a huge part of what we're doing in geometry, we already have the picture drawn out where we take the information and we try to find a relationship between the angles that have the same variables. So this has a 2x, and this has an x, this has an x. So what's true about them? Does it mean they're equal to each other? I'll tell you what, a lot of students look at this and just say, oh, they're equal to each other. No, not necessarily. You have to go by the information. It doesn't say that it bisects that angle. It just says it's perpendicular. So this 2x right here and this 5x plus 6 are not necessarily equal to each other, but they do something. They add up to be a right angle, or they add up to be 90 degrees. So what I'm going to do is I'm going to take the 2x and I'm going to add it to the 5x plus 6. If I add these two angles together, what do I form? A 90-degree angle. So that's equal to 90 degrees. You've got to see the relationship between them. They don't form a straight line. Okay, they're not equal to each other, but they do form a right angle. They do form 90 degrees, so I set them equal to 90. Let's do the math quickly. 2x and 5x is 7x. Subtract a 6 from both sides and we get 84. Okay, and then divide by 7, and then you get, what's that, 12? So x is equal to 12. Now, they don't ask you to solve for a missing angle or anything. They don't ask for angle STW. Now, they could, though, on a quiz or a test. You've got to be careful. They don't always just say, okay, just solve for x and y. Sometimes they'll say, find angle STW. And so you're going to have to take that 12, put it in there. 2 times 12 is 24. So this angle would be 24. Now, they don't ask you to do that in this problem. They just say, find x and find y. Let's go back to this one. Let's do y right here. Remember I put that little box there? 4y minus 2, that whole big angle right there is what type of an angle? Well, it's a right angle because it's perpendicular. All right, so 4y minus 2 also has to be 90. So that's what I'm going to write. 4y minus 2, I'm going to set that equal to 90. And now I can do some basic algebra. Aren't you glad you learned your algebra last year? And then I can solve for y. So let's do that quick. 4y, add a 2 to both sides, that's 92. And then I divide by 4 on both sides. And you do the math real quick. I have it in front of me, but it's 23. All right, so y is equal to 23, and that's all they want you to do. They just want you to solve for x and y. All right, not much longer. I'm going to just take a look at this real quick. I'm not going to go through every little thing here, but what I want you to do, this is in the book, what I want you to do is look at this and just kind of understand. There are some things that you can assume when you see a picture right here, okay? All points shown are coplanar, which means you're not going to have a point that is off the paper, okay, call it that. G, H, and J, see right here, it looks like a straight line, so if it looks like a straight line, you can assume that it is a straight line. That's one of the things that you are allowed to assume. Look at this, HM, see HM, and HL, and HK, and GJ, they all intersect at point H. That's an assumption that you can make, because it looks like it does, all right? Sometimes you can't always go by the looks, but in these situations, you can. L is in the interior of MHK. Let's find MHK. MHK is this, and so you can assume that if L is right there, it's in between those two sides, so it's in the interior. All right. I'll let you read off some of those. Here's some things that you cannot assume. Look at HM and HL. HM and HL, look at that. It almost looks like it could be a right angle, doesn't it? But you can't assume it. What is the only way that you can tell if two lines are perpendicular? If they put that little box. For instance, if they put that little box right there, you could say that GH and HL are perpendicular, but they don't have the box there. Just because it looks like they are, watch this. If I did this, if I just put a line here and a line right there, it sure looks like they're perpendicular, doesn't it? It sure looks like it, but if you don't have that little box there, if that little box isn't there, you cannot say that they're perpendicular. Okay, you cannot say that they're perpendicular. So go through some of these and things that you cannot assume, and here's some things that you can assume, and that'll help you out. All right, that's the lesson. Again, I'm tired of apologizing all the time, but I really want to try to keep this under 30, and I went about 35, so I apologize for that. But we have a lot to get through, and I want to make sure I cover everything and I don't skip anything. All right, we'll see you the next day in class.